Welcome back, ladies and gentlemen. This is Dr. Robinson again, and we're going to continue our studies. This time we are talking about factoring a polynomial completely. Our vocabulary is prime polynomials cannot be factored into other polynomials with integral coefficients. Factoring a polynomial completely means finding the prime factors of the polynomial over a designated set of numbers. Here are the steps for factoring. Step 1. Look for the greatest common factor. Some people say GCMF, greatest common monomial factor, but look for the GCF. If it's no greater than 1, if it is greater than 1, factor the given polynomial into a monomial times a polynomial. Step 2. Examine the polynomial factor or the given polynomial if it has no common factors. The greatest common factor is 1. Then factor any trinomial into products of two binomials if possible. Factor any binomials that are the difference of two perfect squares, such as such. Step 3, finally, write the given polynomial as the product of all of the factors. Make certain that all factors except monomial factors are prime polynomials. Alright, well, let's look at a problem here, and we want to factor completely by squared minus 4b. So we're looking first to find the GCF, or greatest common factor, that will go into by squared and 4b. Well, I notice they have a b in both of these terms, so I'm going to take out the b. So I'm going to divide by b. I'm going to put my b on the side because that's going to be my GCF. And pardon me, I say GCMF, which is b. And I'm going to divide by b both of these terms, just to show you what I'm left with. I'm left with a y squared, and I'm left with a minus 4 when I divide by b. Now, that's the stuff that I'm left with. If you remember our video on GCMF, we put the GCF on the outside and what's left on the inside of the parenthesis. Now here's where we look a little harder. Inside the parenthesis, we have y squared minus 4. That can be factored because I notice we have a minus sign here, and 4 is a perfect square because I can take the square root of 4, which is plus 2 and negative 2, and I can take the y squared, which is y times y. So I can factor into binomials that inside stuff. So I'll put a y here and a plus 2 and a y here and a minus 2. And don't forget, you got to bring down your b GCF. So I factored everything that was on the inside of the parenthesis, and now I cannot factor anymore. I'm left with b times y plus 2 times b y minus 2. So there is my answer. So I think I'll press this, and yes, b times y plus 2, y minus 2. So there it is when we factor this. So find your GCF, factor it out, and then look inside the parenthesis of what's left, see if you can factor any more. Be careful, look for difference. If you see a difference, a minus sign, and you have some perfect squares, you can use the difference of perfect squares to factor. So look for that. That's common. Here's a question for you. Give it a shot and factor it completely. I hope you understand so far what's going on. If you don't, write down your questions, bring it in, rewatch the video, and see if you can follow along. Here's another question. Let's factor this one. This one's a little bit different, and it's a little bit longer, so let's first write it out again. We got 3x squared minus 6x minus 24. Now I notice they all can be divided by 3. So I'm going to take out 3, or divide each one of these terms by 3, and right over here, GCMF, or greatest common factor, equals 3. So that's the biggest number that I can divide into all of these things. So when I divide, I'm left with x squared when I divide the first term, negative 3 divided by negative 6 divided by 3. That'll give me a negative 2, and don't forget the x that goes with it. The negative 24 divided by 3 gives me a negative 8. So all of that is left inside the parenthesis when I took out the GCMF, the greatest common monomial factor. So when I multiply or distribute this, I'll get back to my original 3x squared minus 6x minus 24. But now is where I have to look inside of the parenthesis of what's left to see if I can factor. Now I have a trinomial here, and I always look to see if my students can play my game where I tell them I'm thinking of two numbers. If you multiply them, you'll get negative 8, which is the last term. But if you take those same two numbers and add them up, you'll get the negative 2. So that's this term. So they have to multiply to give you negative 8 and add to give you negative 2. And if you haven't watched that video on factoring, check it out. So let's see. Let's try 4 and 2, because 4 times 2 is 8, and one of them has to be negative. So I'll put 4 and 2 down here, and one of them has to be negative. And I remember, since I'm adding, and I want the larger number to be negative, the sign to be negative, so I'm going to pick the larger number. So that'll be negative 4, and that's going to be positive 2. And if I check them out by multiplying negative 4 and positive 2, that'll give me negative 8, so it checks out here. And when I add these, but I can't add them, subtract the numbers, choose the sign of the 4 because it is larger than that. So that is 4 minus 2 gives me 2, and choose the sign of the 4, which is negative. So it checks out here. So my numbers, negative 4 and positive 2, those were the numbers that I was looking for. So I'm going to draw a second set of parentheses because that means I can factor this trinomial. And I'll put a negative 4 here and a positive 2 here. Those are the numbers that I was missing. And now all I have to do is factor the x squared and the x times x. So put an x here, so I'll have x minus 4, and put an x here, and I'll have x plus 2, and don't forget, you got to bring down this GCMF, which is 3. So I'm going to have my answer as 3 parenthesis x minus 4 times x plus 2 parenthesis. There is my answer when I factored that down. So let's see. Yes, 3 times x minus 4, x plus 2. So that was a good question. Here's one for you. Try it. I think you'll do a good job at it. Look at the other question as a good model. So if you understand so far, great. But if you're not sure, rewatch the video and write down your questions, and I'll be glad to answer them. All right, here's going to be the last one I'm going to do. And this time we have an interesting one where we have an exponent of x to the 4th power, and we have a minus sign in between, which gives me a lot of confidence because I'm going to start by looking at the difference of perfect squares. So let me take a look. I have 16, so I can take the square root of 16, which is positive 4 and negative 4. So I'm using the difference of perfect squares. So the square root of 16 is 4 and negative 4, and I'm going to take the square root of this, x to the 4th power. That'll give me x to the 2 times x to the 2. And now let me set it up. Put 2 sets of parentheses, x squared here and x squared there, and put a plus 4 and a minus 4. And looks like it's factored, but let me look at what's left. I have x squared plus 4. I cannot factor that anymore, but I look again and I see there's a minus sign here. And now I'm going to look for the difference of perfect squares again. And I have a 4, so let's take a look at that 4. Is it able to be square root? Yes, there are two answers to that. There's a positive 2 and a negative 2. So the square root of 4 is positive 2 and negative 2, and I can take x squared and take the square root of that, which will be x and x. So again, I have another two set of parentheses to draw because I have an x I could put here, and an x I could put here. I have a positive 2, and I have a negative 2. So that factored once again. So that was nice. But over here, I cannot factor this because this is not a minus sign. If it were a minus sign, I would be factoring once again. But I cannot factor this. I would end up with a third term in the middle. So there's nothing I can do but rewrite it. So x squared plus 4 will be that. So my answer is going to be x squared plus 4 times x plus 2 times x minus 2. So there is my answer in factored form. So that was a good one. So you got to really look hard to do these questions when you're factoring. So here's one for you. Give it a shot. This one's a little different. So factor it. If you're having difficulties, bring in your questions. I'll be glad to answer them. I hope you got something out of the video. And remember, give us a thumbs up on YouTube. See you tomorrow in class. Bye-bye.